Hello everyone, welcome to It's All About Economics, and today's topic is median. That is one of the measure of central tendency. And hello, I'm Suraj Sharma. For more details you can email me or you can text me. So what are the objectives of this particular class? In last class we have gone through uh, the concept of arithmetic mean, and we get to know about how we can calculate arithmetic mean and the merits and demerits of that, and the generalization, that is weighted mean. In this particular class we would be focusing on median. That is one of the measure of central tendency, and we'll get to know that how we can calculate median, then the merits and demerits of median, and we'll see that how we can locate median graphically. So use of median. Now, are you using qualitative data? Definitely, you would be needing median for the same. Uh, we want to go for lunch and comparing the cost of lunch for different places. Definitely, you would be needing median. Planning to buy a house, so you would be thinking to go out and get the median housing prices. Uh, Comparing salary of two groups have, for example, comparing the per capita income of two nations, then you'd be needing median. Comparing the salaries of two particular groups, then you would be needing median. So for all these concepts, median would be the right choice over arithmetic mean, because here if you see that if you use arithmetic mean for comparing these things, then you would get misinterpreted measure of central tendency. Because if you want to go for lunch and comparing cost for cost of lunch for different places, and you would be having lots of places which are offering lunch with a minimal uh, cost or with a very high cost. So if you take arithmetic mean as a measure of central tendency, then this would be misleading for you. So here you would be having median would be the right choice for you. Similarly, if you're talking about housing prices or salaries of two groups, definitely you would be needing median. So for example, wage distribution of wealth, if you want to want to compare the wealth distribution in a society, then median age of a sample, not the mean age of the sample, then median salary, median housing prices in a locality, etc. Now, what is median? Median is a positional average. It means that it would be lying somewhere in the data if we arrange the data in a systematic manner. Secondly, it divides the distribution into two equal parts. It means that 50% data would be below the median and 50% data would be above the median. So at least 50% of the values are above or equal to median, and at least 50% of the values are below or equal to median. This is how the median is actually making quantiles of the frequency distribution. Now, how you will calculate it? Step one: arrange data in ascending or descending order first. This is very important. If you want to calculate median, first you will have to arrange the data. Either it is in ascending order or descending order. Then step two, and the first step in two is that identify whether the total number of observations are odd or even. Based on that, at the same time we see whether your data is ungrouped or grouped. This is, we have already mentioned in an earlier lecture, that what is grouped data, what is ungrouped data. Now, in case of ungrouped data, if number of observation is odd, then median is the middle value of arranged data. So here you will arrange the data in ascending order or descending order, and the middle value, let's suppose say there are 5 observation, then the middle of the value is 5 plus 1 divided by 2, that is 3. So third observation would be the median. This is how we calculate median. It's very easy. Now in case of number of observations are even, then what can be done? Now here you would be having two middle points in case of even number of observations. Let's suppose say you have six observations. Now when you have six observations, there is no particular middle term. There are two middle terms, that is third and fourth. So what we'll do, we'll take the arithmetic mean of the two middle terms, and that would be our median. So this is how we calculate median for ungrouped data. Now for ungrouped data, we'll have some examples. Like this is the formula which you can use here. X, we are denoting this by median. And why I'm using 0.5 here, because it is the term that will divide the whole data into two equal parts. So 50% would be lying in the left side and 50% lying on the right side. And if n is odd, then the middle value would be the mean, that is n plus 1 divided by 2. So number of observations are odd. So let's say 5 plus 1 divided by 2, that is 6 by 2, that is 3. So third observation would be the median for number of observations odd. Then if your number of observations is even, then this is how you calculate it. So these are the two middle parts, that is first one is the n by 2 and the second one is x n by 2 plus 1. And we'll take the arithmetic mean. It means we'll add these two and we'll divide it by the number of observations, that is 2 for this particular sample. So this is the arithmetic mean of these two middle parts. Now we'll have one example, and let's suppose we have data as 25, 20, 15, 35 and 18. Here the number of observations are odd, that is 5. So first of all we'll arrange it in ascending order. Let's say 15, 18, 20, 25 is greater than 20, then 35 is greater than 25. We have arranged it. Now what are the number of observations? That is 5 and it's odd. Then median would be the middle value, that is the third observation. How we got this third is by n plus 1 dividing it by 2. So 5 plus 1 dividing it by 2, that is third. So third observation is 20. So our median is 20. Now taking another example, when we have even number of observations, then we'll first arrange this data. 8, 15, 20 is greater than 15, 25 is greater than 20, and so on. Now step 2 is there are 6 observations, so even number of observations, and for that we'll having two middle points, two middle terms, that is third and fourth here. So n by 2, n is 6, n by 2 is third. Then n by 2 plus 1, that is third plus 1, that is fourth. So third observation is 20 plus 25 and dividing it by 2, as we are taking the arithmetic mean of 20 and 25, so 22.5. This is the median for this particular ungrouped data. Now in case we have grouped data, or particularly we have discrete frequency distribution, then how can we calculate it? So first of all we'll have an example, and by that you can understand it. Find the median of the following distribution. So we have values as x 1 2 3 4 5 6 and 7, and we have frequencies of these particular values, x values 5 9 12 17 14 10 and 7. How will do that? We'll have to make first a table that would be depending upon cumulative frequency. So for calculating median, first of all you will have to calculate cumulative frequency, and as already mentioned, that how you will get that cumulative frequencies, you will have to do that for this first value, cumulative frequency would be 5. Then we'll add on the corresponding frequencies of corresponding x values, that is 5 plus 9, that is 14. Then 14 plus 12, that is 26. 26 plus 17, that is 43, and so on. So this is how we get how many total number of observations are there. So there are total 74 observations, and it is evident from cumulative frequency distribution. This is particularly less than cumulative frequency distribution. Now what we have to do next? First of all, we'll have to get that the number of observations are here. 74, that is even. So find n by 2. First of all, we'll get n by 2 as 37. Now we'll find less than cumulative frequency just greater than n by 2. So here n by 2 is 37, and the cumulative frequency which is just greater than 37 here is 43, and we'll see the class of this cumulative frequency. Okay, now corresponding value of x would be the median. So what is the corresponding median here? Corresponding value of x is here it is 4. So the median for this particular discrete frequency distribution is 4 for us. So this is how we calculate median. It's very easy. Find first of all, find cumulative frequencies, add up all those, as you will get n, and find n by 2, and see this cumulative frequency just greater than n by 2. So this is here 43, and corresponding x value, that is the median for you. Now in case you have continuous frequency distribution, as I have already mentioned in previous videos, that what is continuous frequency distribution, it would be having the exclusive type of class intervals. So here you will have to calculate the median of the wages from the following table. So these are the wages, okay, and these are the number of laborers. So here you can see that 0 to 10, 10 to 20, and so on. This is in hundreds. So first of all, what you will have to do, you will have to you will have to make a table of frequency and wages. Then you will have to make a table, a column of cumulative frequency. So this is the less than cumulative frequency, where we'll start with the origin. So 12, 12 plus 18, that is 30, 30 plus 27, that is 57, and so on. Here you will get n. Similarly, find n by 2, that is 50. See, just greater than cumulative frequency, or just greater than 50. So just greater than 50 cumulative frequency is here 57, and see the corresponding wage class, that is 2030. As you have noticed here, that in earlier example, that was that we were dealing with a discrete frequency distribution, so we had a particular x value, but here we had a median class. This is called median class. It means that median would be lying between 20 to 30. Now what you do, you will use this particular formula for calculating median for a continuous frequency distribution. You will have to remember it, that this median is equal to L plus H by F, multiplying it by n by 2 minus C, where L is the lower limit of the median class. So we have got it, the median class, that is 2030, and the lower limit is 20. We have got this. Now h is actually the magnitude of the median class. So magnitude of the median class is 20 to 30, that is 30 minus 20, that is 10 here. So frequency, f is the frequency of median class. What was the frequency of median class? The frequency of median class was 27. So we put 27 here, and this C is the cumulative frequency of the class preceding the median class. So preceding the median class is 10 to 20, and what is the cumulative frequency for that? That is 30. So 30 here, and we will put all the values in the places where they belong to. So L here 20, H is 10, frequency 27, N is obviously the total number of observation, that is 100, and N by 2 minus 30. Further you will calculate it, you will get 27.41. So that is our median for this particular example what we are talking about. Now see, it's very important to note here, if the grouped frequency distribution is not continuous, let's say not exclusive type, then first we convert the classes into exclusive type, and then we calculate median for that. And I've already shown you that how you will make it the exclusive, the inclusive type or exclusive one. So further we are going ahead with an example. Let's suppose that in a factory employing 3,000 persons, 5% earn less than $3 per hour. Okay, now the other from this to 4.5 dollar per hour, 30% earn from this to this, 500 earn from 6.01 dollar to 7.5 dollar per hour, 20% earn from 7.51 dollar to 9 dollar per hour, and the rest earn 9.01 or more per hour. Now what is the median for this particular distribution? So first of all, what you will have to do, you will have to make a table that will collect all the relevant information. So this is the table which actually contains all the important observations. Now here are the earnings in dollars, that is less than 3, from 3.01 to 4.50, for 4.51 to $6, and so on. Now here are the workers which are given in percentage. So less than 3 are actually getting 5%, workers are getting less than 3 dollar per hour wage. And if it is 5%, then we can calculate what is the 5% of 3,000 persons, because total factory members were 3,000. So 5% of this you can calculate it using this formula, and it will be 150. Now for another 580 number of workers, this was from 3.01 to 4.50. Then for another 30%, that is 900, means 30% of 3,000, and they are actually getting from 4.51 dollar to $6 per hour. Then for another 500 employees, it is this. For another 20%, that is 600, actually is a 7.51. And the rest, how you can calculate the rest, add all these and subtract it from 3,000, means total employees. So that is 270. So it means we have got the number of workers, means that is the frequency of these particular earning classes. So that is 150, 580, 900, 500, 600, and 270. We can calculate the less than cumulative frequency for that, starting with the origin. So 150, and in this 150 plus 580, that is 730. 730 plus 900, that is 1630. 1630 plus 500, that is 2130. And 2130 plus 600, that is 2730. And 2730 plus 270, that is n equal to 3,000. So it means we have done the right calculation, because here our total number of employees 3,000, so it is coming 3,000. It means it is right. Now this frequency distribution is actually inclusive type, so we'll have to make it exclusive type, and for that the gap between the successive uh, uh, upper limit of the previous class and the lower limit of the next class is used to make it exclusive. So we have made it exclusive by this below 3.005. This 005 we got it from this difference. The difference between these two is point 0.01, and if you divide 0.01 by 2, you will get 0.005. So we'll we have added this in this 0.005. Now similarly, subtracted, added, subtracted, added, subtracted, 0.005, added 0.005, 0.005, subtracted, added, and we have got this class interval, that is exclusive type. Now what we will have to do, we'll just have to put it in the formula of this. We'll find n by 2. Obviously n by 2 would be 1500, because there are total 3,000 employees. Now see the less than frequency, cumulative frequency just greater than 1500. So it was actually just greater than 1500, this class frequency, that is from 4.505 to 6.005. Fine, so we have got this median class. Now using this median class and the frequency that is 900, and this previous classes cumulative frequency, will put all these into the formula of median, and as you calculate this, you will get median wage per hour as $5.79 per hour. Now merits and demerits. Finally, merits. It is rigidly defined as arithmetic mean, easy to calculate and understand, and can be located by inspection, which was not in the case of arithmetic mean. Uh, it is not at all affected by extreme values because we arrange the data and we just pick up the middle value from that frequency distribution. So it is not actually affected by the extreme values. It can be calculated for distributions with open-ended classes, which was not in the case of arithmetic mean. So they're having some additional merits. Now, the median is having some demerits, like in case of even numbers of observations. Now, median cannot be calculated exactly because here you need two middle points and then you calculate arithmetic mean and then get your median. So actually, to calculate the median, you're helping, you're taking help of arithmetic mean. So this is the one of the demerits. It is not based on all observation. Next is it is insensitive measure because it is not sensitive to extreme values, not amenable to algebraic treatment. In case of arithmetic mean, that was very fruitful when we go for further algebraic treatment, but in case of median you cannot do that. Compared to arithmetic mean, median is affected much by fluctuations in sampling, and this is one of the weaknesses of or demerits of median. Now how you will locate it graphically? So for doing that you will have to use ogives. What actually the ogives are? Ogives are scatter plots made using less than cumulative frequency on y-axis with upper limit of class intervals in on the x-axis, and another using more than cumulative frequency on y-axis and lower limit of class intervals in the x-axis. So the first one is called less than ogive and the second one is called more than ogives. And when you plot these ogives in a single plot, in a single xy graph, then the intersection of these two represents median for a particular frequency distribution. I will show you how you will plot this. It can be easily plotted in Excel. So this is the less than ogive. As you can see that these are the cumulative frequencies and these are the corresponding class intervals that and the upper limit of class intervals. Okay, and this is called less than ogive. Now this pink one or the orange one is the more than ogive, which was actually made using the more than cumulative frequencies and the lower limit class intervals, and this is how you make it. Now the intersection of these two, just put it put a straight line here and you will get the median from this. So this example was taken from the earlier example what we have done for the hourly wages and number of employees. So it is actually 5.79 and you can see that this is very much similar to 5.79, just less than $6. So this is how you can locate median graphically. So thank you so much for being with me, and in next class we'll be particularly focusing on one of the measures of central tendency, that is mode. Thank you so much.